Pre-calculus lesson 7-1, basic trigonometric identities. We're going to learn about trigonometric identities and how to solve different equations. Okay, so the first example, it asks us to prove that the sine of x times the cosine of x equals the tangent of x is not a trigonometric identity by producing a counterexample. All you need to do is find something to plug in for x. I'm going to use pi over 4, which is the same thing as 45 degrees. Okay, so plugging pi over 4 in for x. Okay, if you have your graph here, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi, okay? Pi over 4 is the same thing as 45 degrees. It's going to be in your first quadrant, okay? If you were to draw your reference triangles, the opposite side is square root of 2, the adjacent side is square root of 2, and the hypotenuse is 2, okay? If you don't know your reference angles, then you'll have to go back and look those up, or I can send you guys a link. Okay, so the sine of pi over 4. Sine is opposite over hypotenuse. I wrote this down for you guys. So opposite is square root of 2, and the hypotenuse is 2. Cosine is adjacent over hypotenuse, square root of 2 over 2. Tangent is opposite over adjacent. It's the same thing as sine over cosine. So square root of 2 over square root of 2. Okay, multiply these together. Square root of 2 times square root of 2 is just 2. Square root of 4, which is 2. 2 times 2 is 4. These cancel and become 1. This is not the same. So this right here is your work. Your work is your answer, okay? Because they ask you to prove that this is not a trig identity. You prove it by using a counterexample, which in this case, we replaced x with pi over 4. You could do pi over 2. You could do 5 pi over 4, whatever you want, okay? I just like to keep it in the first quadrant because it helps keep things a little bit simpler. So this right here, all of your work is your answer. So now I'm going to show you some reciprocal identities. Reciprocal means if you just flip it over, what do you get? Sine of theta is the reciprocal of 1 over cosecant. Cosine reciprocal is 1 over secant. The reciprocal of tangent is 1 over tangent. Reciprocal of cosecant is 1 over sine. See that? The reciprocal of secant is 1 over cosine. And reciprocal of tangent is 1 over tangent. Again, I wrote this down over here for you. Sine, if you had a reference angle, sine is opposite over adjacent, or the opposite side over, the opposite side over the hypotenuse. Cosine is adjacent side over hypotenuse, and tangent is opposite side over hypotenuse. If you don't have that memorized, this is a way you could memorize it by using, it's not an acronym, but whatever this is called, a little cheating way to remember. Oscar had a hold on Arthur. Take the first letter of opposite, so you have Oscar. H, had, adjacent, A, hypotenuse, hold, opposite, on, adjacent, Arthur. So Oscar had a hold on Arthur. As long as you keep them in the same order, sine, cosine, tangent, you'll be able to remember opposite hypotenuse, opposite adjacent. If that doesn't work for you, then you can use a different way, okay? That's how I remember it from when I was a kid. Quotient identities. Sine of theta over cosine of theta equals tangent, which again I said up here. Tangent is the same thing as sine over cosine. Cotangent is cosine over sine. You just flip it over because tangent and cotangent are reciprocal identities. Pythagorean identities, I wrote this here. Pythagorean theorem is a squared plus b squared equals c squared. These all have that form. A squared plus b squared equals c squared. A squared plus b squared equals c squared. A squared plus b squared equals c squared. They're all in the form, the Pythagorean theorem form, okay? So we have sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. All the Pythagorean identities have 1 in it, the number 1. And then the trig identities are going to be squared. We're going to use reciprocal, quotient, and Pythagorean identities to solve different functions, okay? The first example, it says use the given information to find the trigonometric value. If the secant of theta is 3/2, find the cosine. So you want to look at your identities that were given to you and see if you can find secant and cosine together. Sine, cosine, and secant. Okay, they're reciprocals identities. So if they're reciprocal, a reciprocal means you're just going to flip the fraction. So if secant is 3/2, then cosine's you're gonna flip the fraction 2/3. Now, that's the fastest way to do it. You can always write this out, that cosine of theta equals 1/secant of theta. That's our reciprocal identity. You can plug in 3/2 here, and you can solve by multiplying by the reciprocal. On the bottom, it's all going to cancel. 1 times 2/3 is just 2/3. We get the same answer. If you can figure it out like this, that secant and cosecant are just reciprocals, so you flip the answer, or flip the fraction. Okay, if the cosecant of theta equals 4/3, find the tangent of theta. So now we need cosecant, which right here, and tangent here. They are not reciprocals of each other. So let's go down to our quotient identities. We need cosecant and tangent. Here's tangent, but no cosecant. Cotangent, but no cosecant. Let's go to Pythagorean identities. Nope. Tangent, no cosecant. Cotangent, cosecant. Okay. I think we could probably use this one because it has cosecant in it. And cotangent, we know cotangent and tangent are reciprocals. They're a reciprocal identity. So let's use this one. 1 plus cotangent squared equals secant squared. Cosecant squared. Okay, we're looking for tangent. So first, we're going to solve for cotangent first because they told us what cosecant was. We're going to solve for cotangent first. You can do it one of two ways. If you want to right now, subtract 1 from both sides, so you get cotangent by itself. It might make life easier. So it's going to be cotangent squared equals cosecant squared minus 1. Might make your life a little easier. You don't have to do that, but that's how I like to do them. So let's plug in 4/3 for cosecant squared. So it's 4/3. Don't forget to square this, minus 1. 4/3 squared, it's 4 squared, which is 16. 3 squared, which is 3, minus 1. If we rewrite this by multiplying 3/3 right here by 1, you have 16/3 minus 3/3. 16 minus 3 is 13/3. I feel like I'm not doing that right. You guys, I didn't square the 3 on the bottom. Don't do what I'm doing. Okay? You too can do what I do. Okay, I squared the 4, but I didn't square the 3. Don't forget to square the 3. Okay, so we have 16/9, which is 4/3 squared, minus 1. I'm going to make them have the same denominator, so I'm going to multiply 1 by 9/9. 16/9 minus 9/9. 16 minus 9 is 7/9. That's what the cotangent squared equals. We don't want cotangent squared. We want to solve for cotangent. To do that, we take the square root of both sides. Since this is squared, they'll cancel. You'll just have cotangent of theta equals plus or minus, whenever you take the square root of 7 over the square root of 9, which is 3. That's what cotangent is, but we're looking for tangent. They are reciprocals of each other. Just flip the fraction. So tangent of theta equals plus or minus 3 over the square root of 7. But you cannot leave a radical in the denominator, so we're going to get rid of it by multiplying the top and the bottom by square root of 7. Okay, so the tangent of theta equals plus or minus 3 times the square root of 7, which stays the same, square root of 7 times square root of 7, which is 7. That's what the tangent of theta equals. Okay, now we have symmetry identities, and I'm going to show you my book. Okay. Let me try and move this a little bit. Okay, so I would suggest you take a picture of this, especially this graph right here will really help you identify symmetry identities. Okay, when there's a relationship between the two angles, you're going to have symmetry identity. Your first case is when the angles differ by a multiple of 360 degrees. So if you were to graph them, it's going to end up being the same angle. Okay? So if you had 45 degrees and 9 pi over 4, I'm sorry, 45 degrees and 405 degrees. You graph them both, they end up being the same line. They're in quadrant 1. They both end up being in quadrant 1 on the same line. That's going to be your first case. The values of sine and cosine are the same. They don't change. The second case is when your angles differ by an odd multiple of 180 degrees. So think about it like if someone says, whoa, they did a 180, it means they turned around or they went the opposite direction that they were going. Okay? So these guys, for the second case, is when your angles differ by an odd multiple of 180 degrees. They're going to be opposite each other, diagonally opposite. So one could be in the first quadrant and the other one would be in the third quadrant. If your first angle was in the second quadrant, then your second angle would be in the fourth quadrant. They're going to be diagonally opposite of each other. And the values for sine and cosine both change signs. The third case is when you add two angles together and you get a multiple of 360 degrees. So if you added two angles together, you'd have a multiple of 360 degrees. Here, the angles differ by 360 degrees. They end up being the same angle. Here, you add something to your angle that you're already given, and it ends up being that whatever you added makes it those two angles be a multiple of 360 degrees. They're going to be in different quadrants. They're going to be adjacent to each other, which means next to, but they're only going to be vertically adjacent, meaning either in the first and fourth quadrant or in the second and third quadrant. That's it. Vertically adjacent. The sine values are going to change, but the cosine values stay the same. Sine values will be opposite. The fourth case is when you add two angles together and you have an odd multiple of 180 degrees. So first and third case are similar, about the 360 degrees. Second and fourth case are similar, about 180 degrees. But the difference between 3 and 4, it's you're adding two angles together to get to the multiple of 360 or the odd multiple of 180 degrees. So if you were to add two angles together, the one that's given to you and one other angle that we figure out what it is, and you get an odd multiple of 180 degrees, that's going to be case 4, and they're going to be adjacent to each other like this one, but they're going to be horizontally adjacent. So think of the horizon, okay? It's either going to be in quadrants 1 and 2 or in quadrants 3 and 4. The sine values stay the same, but the cosine values are opposite, okay? I'm not even going to look at this down here. This right here does show you how to solve them, but I think it might be a little bit easier if you kind of use your brain and think about it, and I'll show you. Okay, it says in our next example, I'm going to move this up again. Express each value as a trigonometric function of an angle in quadrant 1. They want your angles to be in quadrant 1. So they told us the sine of 600 degrees. We're going to work with sine, okay? You need to relate this 600 degrees to an angle in the first quadrant. So if we were to add something to 600 degrees, let's see if it's going to be an odd multiple of 180 or if it's going to be a multiple of 360. Okay, so 600 degrees, if you were to graph it, 0, 90, 180, 270, 360. 600 degrees is going around the circle more than one time. 1, 360. Keep going, going, going. You end up down here at 240. Oh, it's more like this. 240 is more like that. Okay, you end up down here at 240. This is 600 degrees. They want our angle to be in the first quadrant. So from 180 to 60 to 600, it's 60 degrees right here. That's the difference between 180 and 600. They want to us to express our angle in the first quadrant. If you were to go opposite this 600 degree angle, you'd be in the first quadrant at 60 degrees. We have opposite angles. That is the second case. They differ by an odd multiple of 180 degrees. From 60 to this angle right here, which if you forget the 200, it's the same thing as 240 degrees. The difference there, 240 minus 60 is 180. So from here to here, it's 180 degrees. So they differ by an odd multiple of 180 degrees. It's not a multiple of 1, it's actually a multiple of 3. So if we go around here, we get 1, 2, because that's 360, and then 3 gets us to 600. So an odd multiple of 3, if you do 3 times 180, you'll get all the way around to here. Okay, so our answer is the sine of 60 degrees, but in the second case, it says the values for sine and cosine change signs, so it's going to be a negative 60 degrees. Okay, now 19 pi over 4. What could we add to 19 pi over 4 to get us either to 300 and a multiple of 360 or an odd multiple of 180? Okay, so the denominator is 4. You're working with, in this case, 45 degrees, okay, at a time. So let's see if we add, just forget the sign, if we add pi over 4, which is the same thing as 45 degrees, let's see what we get. 19 plus 1 is 20 pi over 4. Reduce that, you get 5 pi. 5 pi, if you were to go around the circle, zero, pi over 2, 3 pi over 2 and 2 pi. If you were to go around the circle 5 pi times, or 20 pi over 4, okay? I'm going to show you. Pi over 4 is 45 degrees. You get 2 pi's over 4 for each quadrant. So if you go around 8 pi over 4, that's the same thing as 2 pi. So if we go around once, that's 8 of these. Twice is 16 of these. And we need to get to 20. 17, 18, 19, 20. We end up right here at pi, which is the same thing as 180 degrees. And we had an odd multiple. This 5 pi, 5 is an odd multiple, okay? So we have an odd multiple of pi, or 180 degrees. We're going to use the fourth case, where we added an angle here, and we got 20 pi over 4. We got an odd multiple of 180 degrees, or an odd multiple of pi, okay? So this right here is going to be the pi over 4 is what we added to it. That's what our sine is going to be, the sine of pi over 4. And because it's the fourth case, the sine value is going to stay the same. Cosine value would change, sine value would stay the same. I'm going to show you like what it would look like if they actually graphed the 19 pi. Okay. We found that 20 pi was right here. So 19 pi, just back it up 1 pi over 4. This is 19 pi over 4. Pi over 4 is right here in the first quadrant. They are horizontally adjacent. So again, if you graph them, sometimes if you graph them, it'll make a little bit more sense to you. If you don't know how to graph like this, talk to me. I can help you out, okay? Cosine of negative 410 degrees. If there's anything that we can add to make it a multiple of 360 degrees, or subtract to add or subtract to get a multiple of 360, or an odd multiple of 60. Okay, we're working with degrees here. Okay, we have negative 410 degrees. So we go around negative, so we're going clockwise, 360. If we go to 410 right here, it's 50 more degrees. It says negative 410 degrees. So either we keep going, so we went to here, either we keep going to get an odd multiple of 180, or we go back to 360 degrees, or in this case, since we're negative, it'd be go back to negative 360 degrees. Let's go to negative 360 degrees. Do that by adding a positive 50 degrees. Because remember, the difference between here and here is 50 degrees. So add a positive 50. So negative 410 plus positive 50 is negative 360 degrees. So this right here is a multiple, or if we do negative 410 plus 50, it's a multiple of 360 degrees. We added two angles together to get a multiple of 360. So we're in case 3 here. Okay, if I were to graph 50 degrees, it's in our first quadrant. Negative 410 is in the fourth quadrant. They are vertically adjacent. That is the third case. Again, another way to show it's the third case. So we added 50 degrees. We have the cosine of 50 degrees. When you're in the third quadrant, the cosine values, when you're in the third case, the cosine values stay the same. So it's going to stay as the cosine of 50. Next, the tangent of 37 pi over 6. So we're working in multiples of 30 degrees. Or pi over 6, okay, is the same thing as 30 degrees. Okay, we have to see if there's something that we can add to make this a multiple of 360 or an odd multiple of 180. So let's see here. I'm going to show you pi over 6 is the same thing as 30. So 30, 60, 90, 3 times in each quadrant you're going to hit an angle. So 1 pi over 6, 2 pi over 6, 3 pi over 6. Okay, so if you go around the circle, you have gone 2 pi, or the same thing is 12 pi over 6. Okay, let's see if we keep going. That's 24 pi over 6, 2 times around. If we go 3 times around, it's the same thing as, 24 pi over 6. You'd add 12 more to that, and you'd get 36 pi over 6. So we're almost to 37 pi over 6. 37 pi over 6 would be right here. 37 pi over 6. The next closest angle is not 180. We'd have to go further or go back quite a bit. If we go back right here to the 2 pi or 360 degrees, if we go back here, the difference between the two is pi over 6 or 30 degrees, okay? That's the difference between the two. So if we went around the circle 3 times, the difference is pi over 6. So pi over 6 right here is going to be our angle. And look, 37 pi over 6 and pi over 6, if you graph them, they end up being the same line. So that's the first case. So it's case 1. So pi over 6 is going to be our angle, and we have the tangent of pi over 6. You do want to think of this in terms of sine and cosine and then change it to tangent because it's in the first quadrant. So if we write it in terms of sine and cosine, it's the sine of pi over 6 over the cosine of pi over 6. Remember, sine over cosine is the same thing as tangent. But In the first case, sine and cosine have the same value. So they're both positive because they're in the first quadrant. Sine and cosine are both positive. So we will keep our answer as the tangent of pi over 6. If sine was positive and cosine was negative, this would change to a negative tangent pi over 6. Okay, so now let's look at opposite angle identities. The sine of negative a, or a negative angle, equals negative sine of a. Cosine of negative a, or negative angle, is positive cosine of a. So keep that in mind when you are solving questions. Last one, simplify the sine of x plus the sine of x times cotangent squared x. We need to solve this. You want to keep it in terms of sine and cosine, or even reciprocal identities, as your final answer. So look here. Sine x and sine x are in both terms. Let's factor sine of x out. If we factor it out of the first term, we have 1. Out of the second term, we have cotangent squared x. All I did was factor. Now this looks like a Pythagorean identity because there's a 1 in there and there's a squared, a function that's squared. So the 1 plus cotangent squared right here is the same thing as cosecant squared. I'm going to replace this guy with cosecant squared. Okay, so we have sine of x times cosecant squared x. So I just replaced 1 plus cotangent squared with cosecant x, the reciprocal identity. Now, it's not simplified quite yet. Let's see if there's something we can get in common with these two. Cosecant is the reciprocal of sine. Cosecant is 1 over cosine. So let's replace this with 1 over cosine. So we have sine of x times 1 over sine squared x. Don't forget it's squared because cosecant right here is squared. You can cancel this sign and one of the signs here. So you have 1 over sine of x. Don't leave it like that. You can still simplify it one more step. 1 over sine of x is the same thing as cosecant of x. And that right there is the answer. I will put your homework up and let you know what you have.